Hello everyone, welcome back to my YouTube channel Nursing with Beatrice. In today's video, I'll be looking at dosage calculation part 3. So this one will be on weight based. I've done a video on part 1 which is on oral medication. I've done a video on part 2 which is on injectables. So if you have not watched them, remember to check them out. So today we'll be looking at weight based calculation. So this one, there are some things I want you to take note of. At the end of this lecture today, you should be able to know how to convert body weight from pounds to kilogram, from kilogram to pounds. You should know how to calculate dosages based on milligram per kilogram. Then you should know how to determine whether a dosage is safe to give or if it's not safe to give. And then you should know how to convert body weight also from ounce to pounds, then to kilogram, because at times they may give you a calculation and they will give you the weight in pounds. At times they may give you the weight in ounce. At times they may even give you the weight in both ounce and pounds. But at the end you are ending it back to kilogram because it will be expressed in milligram per kilogram at the final dosage. So you want to know how to do that. Then I want you to take note of this formula here. 1 kilogram is 2.2 pounds. 1000 gram is 1 kilogram. And 1 pound is equals to 16 ounces. We'll be using it to calculate right now. So let's begin. So let's look at some of these examples. So example 1 says, convert 35 pounds to kilogram and round to the nearest tenth. And question 2 is, convert 15 pounds, 4 ounces to kilogram and round to the nearest tenth. So I want us to know how to do this conversion before we go into the dosage calculation proper. So let's look at the first one that says 35 pounds to kilogram. So it's saying we should convert 35 pounds to kilogram. We know the formula is 1 kilogram is equals to 2.2 pounds. So let's do this arrangement method where we do like a proportion or a ratio. You will do that, you will never get it wrong. So 35 pounds, we put it under pounds. So have 35 pounds. And then we're now looking for x in kilogram. So by cross multiplication, it means s will multiply 2.2. So s in kilogram will multiply 2.2 equals 35 will multiply 1. So meaning x, which is going to be in kilogram, will be 35 divided by 2.2 because we are dividing anything attached to x. So if we do that, so we have x, that will give us 15.90. Now, that's kilogram, but they said we should round up to the nearest tenth. So if we do that, s will be approximately 15 points. Nearest tenth means immediately after the decimal, 10 has 1 0. So that means we're ending it at this one. If we're ending it at this, anything here, if it is up to 5, we'll round it to 1 and add it here, but this is just 0, so it still ends at 9. So it's approximately 15.9 kilogram. So that will be the weight. So let's look at this question. It says we should convert 15 pounds, 4 ounces to kilogram. So there are two different units here that we're taking back to kilogram. So first, let's convert ounce to pounds before we move everything to kilogram. So we know the formula that says 16 ounces equals to 1 pound. So since we are converting 4 ounces, so put 4 here, ounce. So it's on the same line, equals to x in pounds. Then by cross multiplication again, so we know that x pound multiplied by 16 ounce will give us 4 ounce multiplied by 1 pound. So that means x pound equals 4. 4 times 1 is 4. So we are dividing both sides by 16, divided by 16. S pound will give us 0.25. So S equals 0.25 pounds. Now, at this stage, I won't be rounding up to the nearest tenth yet, so that we can add it first to 15 pounds. So to add it to 15 pounds plus, it's no longer 4 ounces, it's now 0.25 pounds. So if we add it together, that will give us 15.25 pounds. So now we can round up. So if we round up to the nearest tenth, whatever that is in front of this, we'll turn it to 1 because this is up to 5 already. So we'll turn it to that would approximately 15.3 pounds. So this is the weight in pounds, but our final destination is kilogram. So we know that 1 kilogram equals to 2.2 pounds. So say 1 kilogram equals to 2.2 pounds. So we're looking for the answer in S kilogram equals to, we already have 15.3 pounds. So if we cross multiply, our S in kilogram will equals 15.3 divided by 2.2. This will give us 6.95. But we're rounding to the nearest 10. So this is up to 5. We'll turn it to 1, it becomes 10. Remove the 1. So the final answer will be 7.0 kilogram. So this will be our final X. So now let's just look at how to calculate safe dosage. So let's see an example. This example, the order says Visterion 12 milligram intramuscular Q4 hours, PRN for nausea. The child weighs 40 pounds. Now the recommended dosage is 0.5 to 1 milligram per kilogram Q4 hours PRN. Determine if this dosage is safe to give. So we're determining if the dosage is safe to give, but first we're going to convert 40 pounds to kilogram before we can do our calculation. So first, we have 40 pounds. We want to change it, convert it to kilogram. We remember again that 1 kilogram equals to 2.2 pounds. So 40 pounds, we're looking for the answer in kilogram. So by cross multiplication, so we know that X kilogram times 2.2 pounds will give us 40 pounds times 1 kilogram. So we know that S kilogram will be 40 divided by 2.2 pounds. So 40 divided by 2.2, this will give us 18.18. So that will be approximately S equals to 18 point. So to approximate this, so this is more than 5, we turn it to 1, add it to this, it becomes 2, 18.2 kilogram. So that's the first step. We've converted 40 pounds to kilogram. So to determine now if the prescribed dosage is safe, we need to look at the recommended, but we need to do a calculation first. So the question says the recommended is 0.5 to 1 milligram per kg. So this 0.5 is the minimum, this 1 is the maximum. So first we determine the minimum dose. So the minimum dose will be 0.5. It says 0.5 per kilogram, meaning times the weight, 18.2. This will give us 9.1 milligram. Now let's determine the maximum dose. So the maximum will be 1 multiplied by the weight, which is 18.2, because it says 1 milligram per kg. This will give us again 18.2 milligram. This is the maximum. Now, how do we know if the dosage is safe? If we look at the question again, the prescribed dosage is Vistry 12 milligram, and the recommended is between 9.1 milligram and 18.2 milligram. So if you see 12 milligram is within this range, it's safe to give, because if you look at the frequency, it says 12 milligram of Vistry IM Q4 hours PRN. The recommended is 0.5 to 1 milligram per kilogram Q4 hours PRN. So looking at the range 9.1 and 18.2, which is the minimum, the maximum, 12 milligram is within that range. And since the frequency is the same, which is Q4 hours PRN for pain, we'll say it is safe to give. So let's look at example 2. So the question says order gentamicin 40 milligram IV piggyback Q8 hours for a child weighing 40 pounds. The pharmacy supply is gentamicin 80 milligram per 2 ml. The recommended dosage is 6 to 7.5 milligram per kilogram per day, divided Q8 hours. So question 1 says, is the other dosage safe? And B says, if safe, how many ml of the medication will you put in the bag? So let's analyze the question. The gentamicin is 40 milligram IV piggyback Q8 hours for the child that is weighing 40 pounds. So we are going to convert 40 pounds to kilogram. The next thing, we are looking at the pharmacy supply is 80 milligram per 2 ml. So you take note of that. And then to calculate it, they say recommended dosage is 6 to 7.5 milligram per kg per day. Take note of this per day, because the prescription is Q8 hours. So when we are doing the calculation, we know that 8 hours in 24 hours, because a day is 24 hours, that will be 8 divided by 24, which will be 3 divided doses. So we want to take note of that, so that when we calculate, we won't just conclude and say, oh, it's not safe. We want to first of all divide it to correlate with Q8 hours. So the first thing is, let's convert 40 pounds to kilogram. So 40 pounds to kilogram. So we did it before. We know that 1 kilogram is equals 2.2 pounds. So 40 pounds S kilogram. If we cross multiply, so S will give us 40 divided by 2.2, which will give us 18.18. But to the nearest tenth, this will approximate to 18.2 kilogram. So this is now the weight of the child, no longer 40 pounds. Now, the next thing is to determine if it is safe. To do that, we need to bring out the recommended dosage. So the recommended is 6 to 7.5 milligram per kg per day. Take note of this day. So the minimum is 6 per kg times 18.2, which is the kg. That will be 109.2 milligram per day. But remember, the prescription is Q8 hours. So in a day, we have 24 hours. So if it is every 8 hours, so 8 divided by 24 will give us 3. So if we use that now, we'll be dividing this with 3. So that means 109.2 divided by 3 will give us 36.4 Q8 hours. So milligram. So this is the minimum dosage every 8 hours. No longer, because this is per a whole day. So let's look at the maximum. So the maximum says 7.5 milligram per kg, so times 18.2, which will give us 136.5 milligram per day. But we need it Q8 hours. So we're also going to divide by 3. If we do that, the maximum will now still remain as 136.5 milligram divided by 3, which will give us 45.5 milligram Q8 hours. So now question A says, is the dosage safe? How do we know if it's safe? The prescribed dosage is 40 milligram. So let's look at the range. The range is 36.4 milligram as minimum to 45.5 milligram as maximum. So 40 milligram, which is prescribed, is within this range, so it is safe. So let's look at the second question. The second question is saying, if the dosage is safe, how many ml of the medication will you put in the bag? So we've determined that it is safe to give, right? It is safe to give. So to do that now, to calculate how many ml we'll give, we use our former formula we've used in our first video, our second video, which is amount to give equals to the order dose. This order dose is also called desired, over the available or pharmacy supply, which is also what we call have, what you have at hand, times the quantity. So the order is 40 milligram. The available, what you have at hand, is 80 milligram times 2 ml, which is the quantity. So if this cross out this, 2 times 40 will give us 80. So that's 80 divided by 80, which is 1. Meaning the amount we will give, we'll be putting in the IV fluid, will be 1 ml. So the answer will be 1 ml. That's the amount to give. So that wraps up today's topic on dosage calculation part 3, weight based. If you enjoyed this topic, please like, share and subscribe for more educational content. Thanks for watching.